Hello everyone, I'm Juan, and in this video I will show you how to configure and install TornadoVM for different operating systems. I will explain the prerequisites for TornadoVM, and then I will dive into the installation process for each of the supported operating systems. So we're going to use the latest version available at the time of making this video. This is January 2024. And the latest version is 1.0 and the development one that is 1.0.1. So keep in mind that some things might change if you see this video or you watch this video after January 2024, but I will put a link down below for you to check the latest version available. So first, I want to address quickly what is TornadoVM. So TornadoVM is a parallel programming framework that contains a programming interface, a runtime system, and a set of compiler backends. The goal of TornadoVM framework is to increase performance of data parallel applications that are written in Java by exploiting capabilities of modern hardware. At the time of recording this video, TornadoVM can run on multi-core CPUs, GPUs, graphics processing units, and FPGAs, field programmable gate arrays. Before we dive into the installation process, one more thing I want to clarify perhaps is that although TornadoVM has the VM in it, it's not a new VM. VM stands for virtual machine. But rather, it works as a plugin for existing OpenJDK distributions, such as OpenJDK, Temurin, Amazon Corretto, or even GraalVM. So, as a developer, you can choose which JDK to use in combination with TornadoVM. So, what do we need in order to install TornadoVM? To address this question, let me introduce how TornadoVM is built and the tooling that is needed. The TornadoVM project is almost entirely written in Java and has some sections on part of the code written in C++, mainly for the interaction and connection with the accelerator, for example, the connection with the GPU, and a bunch of configuration files and scripts, mainly written in Python. So software that is needed can be divided into two categories or two dependencies of categories. One is compilers and utilities, such as Python, Git, GCC, CMake, etc. And the second category will be drivers and SDKs. For example, if we're using a GPU, that will be the GPU driver and the CUDA or OpenCL or SPV SDK. I will dive in this later on. So TornadoVM has an installer script, and depending on your operating system, this installation script will download many of the dependencies automatically. As we will see, this is the case for Linux mainly and macOS. But some others, we might need to download some dependencies manually. But okay, that's great. But how do we know which drivers or SDKs to install? To know this, I always like to show this diagram. TornadoVM supports currently 3 backends. One backend for CUDA. This runs on NVIDIA GPUs. One backend for OpenCL. OpenCL is a standard and can run on many different devices, including NVIDIA GPUs, but others could be FPGAs, CPUs, yes, multi-core CPUs, or even M2, Apple M2 M1 chips, as well as Intel HD graphics. This is the integrated graphics that resides on the CPU. And the last backend, or the third backend that TornadoVM has, is the SPV. And the SPV, you need the tooling called Level 0. Level 0 is a very low-level API to dispatch code to run on GPUs currently. And you can get this through the One API, Intel One API SDK. So let's put an example. Let's say in your system, you have an NVIDIA GPU and you want to run Tornado. So what do you need? You need the NVIDIA driver, and then you need the CUDA SDK. CUDA SDK, if you install it, comes with both CUDA and OpenCL. Let's put another example. Let's say you have Intel architecture system, and you have an Intel multi-core CPU and an Intel graphics. What do you need? Well, you need the driver to run on the Intel graphics and the SDK. For example, using one API, you can get applications running there with OpenCL and SPV. Hopefully, this can give you an idea of the type of tooling that you need. In this video, I'm not gonna explore how to install this tooling, but rather I'm gonna assume that this is already installed and we focus just on the pure installation of the TornadoVM project. With that, let's start with Linux. The Linux we're gonna use is Fedora 39, and this machine has a couple of accelerators, has an NVIDIA 3070, RTX 3070 GPU, and has the Intel HD graphics that we can also access through OpenCL and SPV. So we run a couple of commands, NVIDIA SMI to check that we can access the device, and CLinfo so we can see the actual information from all the devices. That comes with the installation of the drivers and SDKs. And now once this is done, we can directly go to the TornadoVM installation. So we clone the repo from the main GitHub repository, where I will put the link down below. And once it's cloned, we can use the TornadoVM script. It's called TornadoVM installer to install all the dependencies. So if we don't pass any parameter, it will print the helper. And one of the options is list JDK. So we have to pass at least the JVM that we want to use, or the JDK that we want to use, and at least one of the backends. You can choose one or two or three. So you can choose even the three of them. So for this experiment, we're gonna use JDK21 and we're gonna enable only OpenCL. But later I will show you how you can enable different backends with TornadoVM without even rerunning the initial script, installer script over and over again. One thing I want to mention is once the installer is done, the goal is to generate, apart from download the dependencies, a file with the environment. So as soon as you source that file of the environment, you can recompile Tornado with different backends without having to reinstall the dependencies. And I will show you an example of that a bit later. For that, let's wait until the compilation is finished, is done. So the first thing to do is to source that file that was mentioned before, and we can check that Tornado can access these devices by using Tornado -- devices. This is kind of a helper in Tornado to say, hey, you can use these accelerators here. And the second experiment will be to run an application. Tornado comes with a few examples, benchmarks. One of them is matrix multiplication 2D that you can see on the screen. And we're gonna run it. The last parameter specifies the input size of matrix size, right? So if you run it, this application will run first a few iterations in a sequential manner, so no parallelism, then a second iteration with parallel streams, and then Tornado. And as you can see, you can get quite a bit of speed ups. You can also, as mentioned before, compile with different backends. For example, if you want to compile with SPV, you do make backend equal SPV. And this will download the dependencies that are required and install the SPV device. And as you can see on the screen, SPV can access the Intel HD graphics. Or you can compile with a PTX backend. In that case, you do make equal PTX. And if you do Tornado -- devices, you can see the PTX device. Or you can combine all of them with OpenCL, SPV, and PTX. And if you do the devices again, you can see all of them. Right. Let's jump now into the installation for OS X, Apple OS X on M2 chips. And it's very similar to the one for Linux. So you use the installer script. We're going to use JDK21 and the OpenCL backend. So one thing I want to mention is that the only possibility for Apple M2 and M1, M2, M3 chips are the backend for OpenCL of TornadoVM. One cool thing is that OpenCL is already pre-installed, the drivers and the SDK, so it's basically plug and play. So we finish until the installation is done, and then we can do the same. So source set vars, this will set up the environment of Tornado, and then you can query the devices by doing tornado -- devices, and then we can see the Apple M2 graphics card. That's great. And we can also run the tests, or we can also run the experiment that we run also for Linux, the matrix multiplication. Remember that this example is going to run first a few iterations with sequential code, then we'll enable parallel threads, Java threads, and then we'll compare those with the execution on the GPU by using the code that TornadoVM generates. And in this case, it's around 60 times faster compared to Java threads. Now we're going to install TornadoVM on Windows systems. I'm going to use Windows 11 and also going to use GraalVM. So know that Tornado can, as it is right now, can be installed natively on Windows, but we can get installation through the MCs tool in a similar manner to the installation for Linux or macOS. So to do that, we follow the instructions here displayed in the website. I'm going to put a link down below for all the instructions. And we're going to follow this tutorial, let's say. So first of all, we need Maven. So we go to the Maven website. We download the latest binary for Maven, and we put it wherever we want on our path. So in my case, I put it on C/bin directory, and I place there Maven. I also pre-download the GraalVM with JDK21 as well in the same directory. And these two, we're going to use it later to specify the path, the Java path and the Maven bin directories. So let's continue with the tutorial. So next step, we download the MCs tool. So if we go to the website, I have it already here. We just download it. I already did this step, and you can place it wherever you want. I also place it in the default directory as the documentation of MC suggested, but you can place it wherever you want. So once you install it, you run the MC64, by the way, be careful. MC64 terminal, and you will get something like this, right? So now I'm on my home directory, and I can basically run almost any Linux command. So let's continue with the installation here. The first thing to do is to update the packages, update the system to update the packages that we need for the compilation of Tornado. In my case, I already did it. That step is done for me. But if this is the first time that you launch, you're gonna see a bunch of updates, right? So next, after all updates are finished, we install the Tornado dependencies, and this basically is installation for installing Make, CMake, GCC, the OpenCL headers, Python 3. And Git, right? So if we run it, obviously I did it myself, so it's just telling me that you want to install something else, no? But in your case, if this is the first time that you run this, you might say yes, and there's a lot of dependencies. You wait, and you get this. Then what we're gonna do is to create the M2 directory. So we go to M2 directory and create a file called settings. So if I open it, that's the content to include in this file, right? So once we do this, we want to specify in our path how to run Maven to be visible from the MCs tool. To do that, I have a PowerShell terminal. It's a different type of terminal, and I locate in the path of MC64/bin, right? So I'm this path. And what I'm gonna do is to create a new file. In my case, I already did it. I'm gonna do with code, by the way. You don't need this line. So basically, in this file, we specify the path to our Maven installation, the final binary, and these flags. Basically, we say, where is our XML file, right? How do we get this path? Well, go back to your Maven installation, click in bin, and then from here you say copy address as text. That's all. Same thing or similar thing later for your Java home. So let's go back to the terminal. Once this is done, we are ready to install Tornado. So we clone the repo. Let's go there. Let's go to the terminal, to the MC64 terminal. Again, I'm gonna locate in home, and I'm gonna clone the project. Just a clone. Right, once the code is there, we are gonna go to that directory, and we are gonna create a source file. Basically, that source file will contain Java home and a few other variables that we need to in order to compile Tornado projects. I already did that, so I'm gonna recover from my backup, but I'm gonna explain to you what I did. So I'm gonna copy here, and basically this is the most important file now to get the Tornado installation process done. So basically we specify the Java home, and here you copy your Java directory. In my case, I installed the GraalVM JDK21, and I place it, remember, I place it in bin, so we just copy that path. And then we need to specify where is our CUDA path. How do we get this? Well, in my configuration, in this machine, I already installed the NVIDIA drivers and the CUDA SDK that contains CUDA. So to get this path, we go to our CUDA installation. It's gonna be something like C programs files. If you install CUDA and you leave it as default, you're gonna find it in the same place. So it's C program files, NVIDIA GPU computing toolkit, CUDA, and then you choose your version. In my case, I'm gonna choose the latest that I installed, 12.1. And I think that's all we need. Oh, maybe we need the bin directory. Let me check. Yes, we only need until this directory. So we are ready. We just copy that path, copy address as text, and let's go back to our terminal, and that's the path we copy here. The rest of the file, you can leave it as it is, right? No matter your configuration, this will work in the case of Windows, this will work for both OpenCL backend and CUDA PTX backend. So once this is done, we are ready to install Tornado. So we do the source to this source file, and we just do make. Let's say we want to install only the OpenCL, so we just type make and done. Right, once it's finished, we can check that we have Tornado installed. We can run this command as we saw for Linux and OS X. Is tornado ---- devices, and it will print it will tell us the devices that Tornado can see to run the application. So we see a bunch of errors. I will explain what it is and why it's generating this. But essentially, we see now in this configuration with this machine 4 different devices: NVIDIA GPU, the RTX 3070, the Intel Integrated Graphics, this is the GPU that is inside the CPU, multi-core CPU, that's great, and an FPGA. This is, by the way, simulation of the FPGA. So why are we getting these error messages? Because it's creating under the hood the context and it's communicating with the device, and is inspecting, is seeing an FPGA. So to run Tornado on the FPGA, we need something else. We need a few other commands. I'm not going to explore this in this video. If this is something you want to see in the future, please leave a comment. I might do a video soon about this. Right, so if you want to compile with PTX, so CUDA backend, you can do that by using this make backend equal PTX, or you can do both PTX and OpenCL, right? So let's do only PTX. And once installation is finished, we can also type tornado ---- devices, and we should see the CUDA backend of Tornado. And also we can run application. Let's say we're gonna run now, because the default is PTX, we're gonna run with that backend. In a separate video, I might explore how to run and tune applications. Let me know in the comments below if you want to see that. But let's try this application. This is a matrix multiplication, parallelized in 2D, so to access thread ID X and Y. And this is the size of the matrix. So let's say we want, well, the default one for 512. If we run it, it will run, I think, first sequential code, then the streams, and then the parallel code. Well, you can get an idea of the speedups you're gonna have. And that's the installation for Windows. That's all for now. Thank you very much for watching, and see you next time.